Hi, my name is Smykla Haruansan. This is EHS 520 Professor Dr. Will at St. Francis University. Today I'm going to talk about PFOA, PFOS, and PFOAA effects to human, animals, and environmental health. So PFOS and PFOA are human-made fluorinated compound substances and are not naturally found in the environment. They are found in the use of DuPont Teflon products and other members of PFAA. PFOS and PFOA are used as surface active agent, coating additives, cleaning products, and as firefighting foam, and widely used in carpet, textiles, leathers, and paper. PFOS and PFOA are extremely resistant to photolysis or biodegrade in environment. 3M study of PFOS found inhibitory effects of both lethal effects on cholesterol biosynthesis in critical periods affect reproductive just because birth. Johns Hopkins study revealed the correlation of infant born with greater levels of PFOS and PFOA to decrease birth weight and head circumference. PFOA levels affects the total circulating of thyroxine level, high concentration, prolonged pregnancy. PFOA as hypolipidemic compounds increasing fatty acid metabolism in utero. Some research suggests that infants born with low birth weight are at risk to obesity, diabetes, and heart disease later in life. PFOA detects in workers' blood in general population geographic region of America. However, the routes of exposure are unknown. The greatest concern of PFOA exposure due to widespread use in ammonium salt that commonly used as C8. PFOA and PFOS are potentially linked to tissue problems, developmental delay, and cancer. So what about the effect to wildlife? Both PFOS and PFOA have a high affinity for binding the 2B lipoproteins and liver fatty acid binding protein, potentially to bioaccumulate, to biomagnify in wildlife, immediately absorbed after the oral exposure stored in serum, kidney, and liver. Potential developmental, reproductive, and systemic effects in animals. The Teflon is lethal for birth because the birth sites and lungs capacity are sensitive to the toxin. At San Antonio Zoo, they had lost 21 birds in outdoor foam lights that installed by the zoo to warm them up because the light bulb has been coated with Teflon. PFOS is accumulated to level of concern in fish tissue and widely used and widely found in Greenland where the polar bear living, throughout giant pandas in China, in the middle of Pacific Ocean. PFOS affect wildlife health is associated with chronic disease, kidney disease. The variety distribution of PFC increase the potential of bioaccumulation and bioconcentration from low to higher trophic level organisms and wildlife, such as fish-eating birds, another biota, continue to be exposed to PFOS and PFOA. The PFOS and PFOS level were detected in Canadian Arctic polar bear's liver. So in study animals, the high doses of both PFOS and PFOAs can cause cancer, physical development delay, endocrine disruption, and neonatal mortality. PFOS and PFOAs can cause neonatal mortality in laboratory mice. PFOS may impede the endogenous surfactants in lung functions. PFAA can induce abnormalities of mouse tissue such as ovaries, mammary gland, and sperm. PFOS detected in birds, fish, and marine and land mammals all around the world. PFOS was detected in the ringed seal blood from the northern Baltic Sea, the eastern Canadian Arctic, and sulfur in the blood or liver of northern fur seals and polar bear in Alaska. So approximately 1 to 5 micrograms per gram per tissue. This evidence is the most prominent organohalogen compounds finding in polar bear. So STSDR found vast amount of PFOS and PFOA were emitted to the air, water, and soil in fluorochemical facilities. PFOA is primarily used to produce salt, that is essential processing of fluoropolymers and fluoroelastomers productions, and has many uses in various industrial and consumer products. It might represent concerns similar to those found in PFOS. Detect in many U.S. cities of surface water, sediments downstream, wastewater treatment and sewer sludge, and landfill leaches. The environmental release of PFOS base come from the tank and supply line leaks, aircraft hangar fire suppression, and firefighting training. PFOS and PFOA are the stable end products degradation of previous substance via abiotic and biotic transformation pathway. The chemical structure of PFC, including PFOS and PFOA, resists typical environmental degradation and atmospheric photooxidation. PFOS and PFOA have very low volatility due to ionic nature, meaning persistent in water and soil. In atmosphere, PFC are predicted to absorb particles and settle in the ground, whether wet or dry deposition. The ionic form of PFOA and PFOS are water soluble and promptly migrate from soil to groundwater. So this is the PFOA and PFOS evidently found in Finland's river waters, wastewater, and sludge samples. Monitoring from Arctic region found PFOS and PFOA in environmental media and biota can have long-range transportation. PFOS does not demonstrate a sign of degradation when boiled in nitric acid for hours. Basically, the more carbon atoms are the longer carbon chains and the persistent in body. In other words, less carbon atom is less time to degrade in our environment. For example, C8 compounds are eliminated within 3 to 8 and 5.4 years. However, with 6 carbon perfluorohexane sulfonate is eliminated in 5.8 years. Because of public safety, some of the products that contain PFOS may need to be extended includes firefighting foam. By 2015, 3M is considering to withdraw the products that contain PFOA and PFOS from the market and will develop a safer substitute called PFAA, which contains fewer carbon atoms. To prevent potential severe long-term consequences and rapid phase-out is necessary and appropriate. However, PFAA and its synergistic chemistry have left the residual and is likely to release back into PFOA and PFOS. Because the PFOS demonstrate lethal effects in animals and wildlife, it is possible effect on human health. So my proposal objective is, can long-term or lifetime ingestion or exposure for months for mother lead to transplacental transfer of PFAA, PFOS, and PFOA? Does in utero exposure and maternal breast milk exposure to PFAA, PFOS, and PFOA leading to long-term effects on humans in any following area? A. Growth failure. B. Developmental delay. C. Premature birth. D. IUGR. Intrauterine growth retardation. Or C. Cancer. Where do we find this chemical in everyday life? So PFOA is one component of Teflon. PFOS, the productivities of scorecard stained metal, which is extensively used in film processing, aluminum manufacturers, electronic preparation, refrigeration, pharmaceutical foundation, and printing. PFAS, physical properties of C8, are excellent surfactants and thus commonly used in more than 200 industrial and consumer applications. Used widely in surface protection products include carpet, clothing treatment, coating for paper, and cardboard packaging to enhance resistance to water and dust, such as microwavable meals, popcorn bags, chewing gum, candies, donuts, pizza, fast foods, mist suppression, and dental floss. Perfluorocarbon can be detected in human body fluids such as breast milk, in the air, in drinking water. Food and water. PFAA can be leached into food in high temperatures processing during preparation of packaging for distribution because several food packaging materials contain residual PFAA and PFOA. Humans can expose to PFOA from food, even organic food. These chemicals can get passed through our system from water, placenta, maternal breast milk, and cause adverse health effects. The non-stick cookware, PFAA, can be emitted into the air and can be inhaled and they undergo extremely high heat. Contamination from the DuPont plants released on landfills. Outdoor and indoor dust are particularly primary sources of exposure for young children contamination due to hand-to-mouth behaviors. Groundwater, public drinking water, air admission have contaminated soil and sediment, while runoff has contaminated groundwater and public water drinking supply. So when infant consumption, breastfeeding increased potential excretion route for mother, an implication for an infant exposure to PFOS and PFOA. These are found in serum concentration 6 to 4% higher per month of breastfeeding, while maternal serum compound concentration were relatively lower in each month of breastfeeding. From drinking formulas prepared by contaminated water. Paint toy. Teflon has been used in rubberized coating in some paints, so all painted toys are likely to contain some PFAA residual. Do PFOS and PFOA transplacental transfer? It's been found in cord blood and being detected in fetus. PFOS is known to have lipid metabolism effects in adult humans and can transfer to human placenta to cause metabolic disorder to offspring, fasting glucose and insulin level. PFOS and PFOA level associated with infant born with low birth weight and small head circumferences. Infant may at risk to obesity, diabetic, cardiovascular disease later in utero. Carmen and friends found the level of PFOS in breast milk sample from a group of 12 Swedish 3 months postpartum women. Thompson and friends conduct a longitudinal study to measure serum concentration in maternal breast milk monthly in 9 women. As a result, during 1 year of breastfeeding, PFOA and PFOS concentration estimate in breast milk fell by 94% to 37% accordingly. Delay and growth retardation are UTR if PFOA exposure during gestation. BCERC biology and epidemiology study found low level exposure precipitate puberty in males, but not in female until high-level exposure were reached. On average, men have higher serum of PFOA level than women. In the US, the median level in adult men is 6 ppb, but 4.6 in women. Study of PFAA by E-screen assay. 5 perfluorinated compounds were found in estrogen-like properties. PFOS is linked to pancreatic hyperthyroidism, liver tumor, in animal study. Chemical compounds migrate down the drain, disposal of consumer products, and release into environment by wastewater system, and contaminate groundwater and drinking water system. Degradation of PFOA in the air approximately half-life is 130 days. Environmental significant unzip cycle with high nitrogen oxide, however, stable under normal environmental conditions in water, soil, sediment, and sludge. PFOA and PFOS in biota. Aquatic species such as vertebrates, zooplankton, and fish, lake trout or pigfish. Terrestrial species, birds, amphibians, and reptiles, such as green fox and snapping turtle, marine mammal, have been found to have PFOA and PFOS. So what about PFOA and PFOS in the ambient air? It was found in rural, marine, herbal, and adjacent to manufacturing. PFOA and PFOS found in surface waters, freshwater, in 6 cities in the U.S. PFOA and PFOS in the oceans. North Atlantic Ocean, Mid-Atlantic Ocean, West Pacific, Central to East Pacific Ocean, Indian Ocean, and Antarctic Ocean. In the wastewater, industrial wastewater treatment, and municipal wastewater in the U.S., including Georgia, Kentucky, Iowa, Pacific, and New York. In Europe, found PFOA and PFOS in Germany and Austria, including Asia, Singapore, and Japan. So the solid waste concentration from incinerators, ashes, and sludge. Drinking water, private drinking water as well, and public water supplies. Methodology to test my hypothesis. Drinking water is assumed to be the main human exposure pathway, so test PFOA and PFOS in the bottles drinking water beverages such as coffee and cola, in comparing the public water and tap water. Then, testing blood during pregnancy for PFOS and PFOA level, particularly in the 3rd trimester period before birth, and maternal breast milk during the first week of delivery, then follow up at 18 weeks, 36 months of ages. Analyze the newborn blood level from newborn screening, whether there is a significant elevation of bilirubin. So a few drops of blood from newborn heals are obtained on the filter paper. The test is simple and safe. The sample is sent to state regional laboratories for testing. The test result will be entered to genetic disease screening program in Richmond. The core study, dividing the pregnancy mother into 2 groups, the test group and the control group obtain serum blood level for baseline level. The control group will only drink the tap water while the test group will drink bottled water, and both groups are restricted to similar diet and environment. After 6-week period of during the 3rd trimester, check PFOS and PFOA level. If the test group would have lessened PFOS and PFOA level in their blood. Follow up after delivery if the mother in the test group will have a higher level of PFOS and PFOA. If the test group is having IUG or premature birth, developmental delay will be determined by use the baby growth chart for newborn term and premature babies. Obtain newborn screening for babies within 12 to 24 hours of life prior to blood transfusion. What is the newborn screen and what is the evidence telling us? The positive newborn screening result identify what newborn are at risk to signal further diagnostic work is necessary. However, the negative result in premature babies sometimes require further study. The disorder that detectable by newborn screen tests are PKU, galactosemia, primary congenital hypothyroidism, sickle cell disease, non-sickling hemoglobin disorder, thalassemia major, metabolic disorder, congenital adrenal hyperplasia, cystic fibrosis. So newborn screen test can detect the following. Basically, it can detect endocrine disorder, primary congenital hypothyroidism, variant hypothyroidism, congenital adrenal hyperplasia, amino acid disorder. So detect other metabolic disorder. So what about long-term developmental follow-up? We testing IQ in school age. We use Bailey scale testing for delayed developmental at 18 to 24 months, 36 months old, and school age. The Bailey scale of infant development is the tool to measure infants' mental and motor development and infant behavior from 1 to 42 months of age. The scale contains 3 scales. Mental scale assess the mental development index. Several types of abilities are evaluated, such as sensory perceptual acuities. Motor scale is assess the degree of body control, large muscle coordination, fine manipulator skill of hand and fingers. Behavioral rating scale obtain information which can be used in mental and motor scale. Other support study found the same result of blood serum sample measuring using a technique called mass spectrometry for PFAA contamination. Isotope dilution mass spectrometry (IDMS) enhance the accuracy of measurement, improve the quality of analytical results in water sample to determine PFOA and PFOS contamination in municipal wastewater. The use of IDMS was publishing quantitatively data to make the data more comparable. Another study investigates the presence of sources of fluoronate alkyl acids (PFAA) in the tap water in Amsterdam City, in Netherlands. Studies have shown despite the low concentration of PFAA in the tap water may pose a high contribution to daily human exposure. Remediating soil, water pollution, and biological treatment technology. We found high-performance liquid chromatography, HPLC, and tandem mass spectrometry (TMS) are the standard method. Common excited water treatment technology activate carbon filters and reverse osmosis unit. Strong fluorine carbon bond and low vapor pressure (PFOS and PFOA) resist most conventional in situ treatment. So what is important question we should ask? What are the short, intermediate, long-term goals for PFOS, PFOA, and PFAA manufacturers? How to stop prevent external pollution? How to increase the safety of public drinking water for being exposure to PFOS, PFOA, and PFAA contamination? What are lifelong effects in the future of these chemicals to human environmental health, since this chemical leave residual in soil and sediment? What method to use to broaden knowledge of environmental effects? My personal solution is that compounds or replacement of chemical compound that has long chain of carbon due to potential risk to human and environmental health. So should the EPA create a law to prohibit the use of these chemicals? Or enforce polluters to maintain current study of commercial products? EPA limited the landfill use reservation for plant sites for manufacturers, encourage the manufacturer and set aside the fund for future study, create an alternative product associated with food, packaging, personal use product, and commercial product, provide appropriate training and providing education to public in relation to chemical compounds and how to prevent secondary exposure.